Welcome! In this video, we will present how to create two-dimensional animations for our simulation using Automation Studio through an example. To demonstrate these animations, we will try to represent the movement of a double-acting cylinder and associate it with the piston of a hydraulic diagram during its simulation. The first thing we will do is represent the piston and rod inside the cylinder as if it were a sectional view, and we will use rectangles for this. This sectional view will allow us to observe the inside of the cylinder and better understand its operation. Once this is done, we will change the appearance of the piston and rod using the shading pattern in the editing screen. In this case, we have selected shading pattern 51 to give it a metallic look, which will facilitate the identification of the components during their simulation. The next step will be to enter the component properties. By right-clicking, we will access the context menu and select the animation section. Here, we will add a translation animation. This animation will allow us to simulate the linear movement of the piston and rod inside the cylinder. We will determine the maximum displacement of this translation and adjust the maximum range of the associated variable. It is important to correctly configure these parameters to ensure a realistic simulation. The only thing left will be to associate the animation with the position signal of our piston in our hydraulic diagram. We will do the same with the rod. And when starting the simulation, we will observe the movement of these two components in a precise and detailed manner. We will now see that there are not only translations for movement animations, but we can also perform resizing of certain figures. For this example, we will divide the inside of the cylinder into two volumes separated by the piston, and we will make the represented volumes increase or decrease based on the movement of the piston. This technique is useful to show how the volumes of the cylinder compartments change in response to the movement of the piston. For this, we will select a color to identify them correctly. In this case, we will use blue and green. This will help to visualize more clearly and understandably the volume variations inside the cylinder. Once identified, we will add the animations as we did before, but in this case, we will select the scale range and increase and decrease each time proportionally. By doing this, we can observe how the volumes change in real time during the simulation, providing a more complete view of the behavior of the hydraulic system. We will also see that it is possible to represent pressure and flow using animations. Before adjusting the animation, we will introduce two pressure sensors at the entrance of each of the pistons and create the associated variables P0 and P1. These sensors will allow us to monitor the pressure variations on both sides of the piston during the simulation. We will enter the component properties of each volume and add a color animation by adding the ranges that will represent the pressure thresholds, allowing us to visualize the pressure changes intuitively. Then we will associate each rectangle with the respective pressure variable and observe how the pressure is detailed inside the cylinder in real time when starting the simulation. Finally, we will also see that we can represent the flow on each side of the piston using a shading pattern. In this case, we will do the same, but adding flow sensors at the piston entrance. These sensors will allow us to measure and visualize the fluid flow on each side of the piston. We will add a shading animation to the rectangles representing each volume. Here, we will also adjust the thresholds and detail the flow speed we want to visualize. Finally, the only thing left will be to associate these two animations with the variables F0 and F1 corresponding to the flow sensor signals. By doing this, we can observe how the flow varies in real time, providing a deeper understanding of the system's behavior. Additionally, there are all kinds of animations such as rotation, visibility, intermittent visibility. These animations can be used for educational purposes to show the operation of our system during the simulation, while also representing pertinent values, whether they are pressure, flow, movement, electrical intensity, voltage. These tools are especially useful in educational contexts, where it is crucial to understand not only the static behavior of components, but also their dynamics and how they interact with each other. For more information about the Automation Studio software, we invite you to visit our website at www.famectech.com. Thank you very much for watching this video.